Hey, I'm Dominic Torno. I'm founder and CEO of Resonate. And today we will talk about sagas and compensation. At Resonate, we are pioneering a novel approach to distributed computing, distributed async await. Distributed async await is an extension of async await that goes beyond the boundaries of a single process and makes distributed computing a first-class citizen. Complex distributed applications consist of complex distributed processes spanning multiple components. But current practices in distributed systems shy away from distributed transactions, challenging us to maintain correctness without the support of transactions. Consider a travel booking application. Booking a trip consists of multiple steps, like booking a flight and booking a hotel. In order for the booking to be correct, the booking has to be complete. In other words, correctness requires completeness. Any partial execution is undesirable. Let's build a minimal computational model. A process consists of a sequence of steps. Here, an individual step is atomic, meaning that the step either executes completely or not at all. The fundamental challenge is that the process, the sequential composition of atomic steps, is not itself atomic. The Saga Protocol guarantees that a process executes atomically. That is, the process executes observably equivalent to exactly once or not at all. In other words, the Saga Protocol guarantees that a process that experiences a failure and then subsequently recovers is observably equivalent to a process that executes exactly once or not at all. To mitigate partial executions, sagas employ two failure mitigation strategies: forward recovery, also called redo or retry, and backwards recovery, also called undo. Forward failure recovery refers to failure mitigation strategies that transition the system from an intermediary state to a state that is equivalent to the final state. In simple terms, we redo or retry our failed step and we proceed. Backward failure recovery refers to failure mitigation strategies that transition the system from an intermediary state to a state that is equivalent to the initial state. So in simple terms, we undo already executed steps. To enable backward recovery, a process should register a compensating step or a compensating action for each executed step. Real-world sagas will typically employ both forward and backward recovery strategies. When encountering a failure, first a saga will attempt forward recovery. If retries fail, a saga will attempt backward recovery. To circle back to our initial example of a travel booking application, if the process fails after booking the flight but before booking the hotel, we attempt forward recovery by retrying to book the hotel. If we exceed the acceptable amount of retries, we will attempt backward recovery by compensation, here cancelling the flight. However, a compensation is itself a step that may fail. What do we do then? In that case, we are out of options. We have to notify an operator to mitigate the partial execution manually. Rolling your own reliable abstractions can be a complex undertaking. Head over to Resonate HQ.io and check out distributed async await to make the development of reliable applications dead simple. Thanks for watching.